All right, section 3.5, we are going to write and graph equations of lines. For our warm-ups, number 1, they said that x is equal to 0. What is y? John, what'd you get?
-4.
-4. How'd you come up with that?
Because if x is 0, then 2 times 0 would be 0.
Mm-hmm.
So then 5 divided by -20 equals -4. So y equals -4.
I agree with most of that. We are taking -20 divided by 5, though. It's common that people will switch those around, and order does matter. But yes, I agree with your thought process there. Y should equal -4. Questions about number 1? Number 2, what do we get as our slope? -17 over 1. Okay, do we all agree with that? We should have done something like take -10 minus 7 and 3 minus 2. And I agree, -17 over 1 or just -17 looks good. Make sure you're taking y minus y on top, x minus x on bottom. Again, more algebra review. A linear equation is an equation that forms a line. It's kind of in the name. Slope-intercept form is? Good. Y equals mx plus b. Slope-intercept form is the general form of a linear equation, meaning that's what we use and see most often. This might be coming up on another slide, but just as a refresher, what does M stand for?
Slope.
M is the slope, and B is the y-intercept. B is the y-intercept. That means it is where the line crosses the y-axis. All right, standard form. Does anybody know that one? Yep.
AX plus BX.
AX plus B y equals C. Where A and B are not both 0, because then you would just have a constant. We got to have something in there, either an X and or a Y. Anybody know point slope form? Starts with a Y.
Isn't like, oh, is it, it's like Y?
Y minus Y1 equals,
No, it's like parentheses.
X minus X1.
close, M times,
X, yeah, and then like X1.
I knew that.
Yeah.
I knew that.
Oh, I remember that.
okay. So in point slope form, the Y, the plane Y, and the plane X would remain Y and X. The only things we would plug into would be the Y1, the M, and the X1. Okay, so again, M is going to be the slope there. And one of our points on the line would be X1, comma Y1. Write an equation of the line in slope-intercept form and standard form. It is always going to be easiest for us to start off in slope-intercept form, and then we can change it or rearrange it into standard. So to find slope-intercept form, I need to identify 2 things. What do I need to find?
Rise over run.
The slope and the y-intercept. I need to know my M and my B if I'm going to do this. So what is my slope, my rise over run?
2.
So I agree my slope should be negative. I was hearing a few different numbers. So my rise in this case, I went down 4 and then over to the right 2. So -4 over 2 simplifies to be -2. Okay. What about my y-intercept?
3.
+3, good, where the graph crosses the y-axis. So for slope-intercept form, I would write y equals negative 2x plus 3. We're just plugging in the m and the b. Again, this should be a review from last year, or whenever it was you took Algebra 1. All right, now that we have slope-intercept form, that is part of our answer because they wanted that. But now we need to rearrange that to also show standard form. Any thoughts on how I could do that? Remember, standard form has x and y both on the left side of the equal. We don't need to use the line anymore. Do what, Detriana? Very good. If we add 2x on both sides, then that's going to get it to cancel off of the right side and move it over to the left side. But instead of writing y plus 2x, I want it to be 2x plus y. We need the x first, then the y, then equals our constant. So this would be our standard form. Questions, concerns? Warm, fuzzy feelings? Okay, are we ready to move on? Write an equation of a line passing through the point 1, negative 1 that is parallel to the line with the equation y equals 2x minus 1. Okay. When they just say write an equation of a line, I would default to slope-intercept form. We might use another form to get there, but that should be our default for writing an equation of a line. First of all, I'm going to need to know my slope. So if I am parallel to this line, what slope do I want to use? 2. I want to use the same slope. So if I'm parallel, I'm using the same slope. I know my slope is 2. So far, what we know about our line is a point and a slope. So what form do you think we could start off in pretty easily? We want to end up in slope-intercept, but I don't think that's where we start. Point slope. They gave us a point, they gave us a slope. It's going to be easiest to use point slope. Does that make sense? And then we can change it into slope-intercept. If they give you a slope and an intercept, then it's easiest to start off in slope-intercept. This time, it's a point and a slope. So, point slope form, I would have y minus what? Negative 1. Subtracting a negative means I'm really adding. So I'll put y plus 1 equals, my slope is 2, so I'll plug that in. Parentheses x minus 1. So this is the point slope form of that line, but I want it in slope intercept form. What do you think I need to do with what we have here? Distribute the 2. Y plus 1 equals 2x minus 2, and then subtract 1 to get y all alone. Y equals 2x minus 3. I know we're going through these quickly, but it should be a refresher from last year. We shouldn't need to start all over with this. But if you have questions, please ask them. All right, number 3 is pretty similar to the last one. We're given a point, but this time we want to be perpendicular to the line that they gave us. Y equals negative 3x plus 1. So if I want to be perpendicular to that line, what do I want my slope to be? Good. The opposite reciprocal, which I heard several people say, 1 over 3. So if we're perpendicular to this line, opposite reciprocal of negative 3 would be positive 1 over 3. So I want you to go ahead and give the rest of this problem a try. From here on out, it's a lot like our last one. Use point slope form and then change it into slope intercept form. All right. Who can tell me the point slope form of this line? Ajay?
X equals 1/3 times x times 3.
Good. Oh, 1/3. Sorry, got ahead of myself. X minus 3. Very good. Are y'all okay with the point slope? Okay. Then to get our slope intercept, we had to do what first? Distribute. It's kind of nice on this one to distribute. We get 1/3 x minus what? 1. Good. Last step is add 2. Y equals 1/3 x plus 1. Beautiful. Questions, concerns? Taylor?
Couldn't you just use that equation and then put the opposite reciprocal slope in there and keep the same y-intercept?
Oh, interesting. On this particular problem, it worked out that they had the same y-intercept, but it will not always be that way. Does that make sense? Okay. So we can't rely on that every time. That's just kind of a coincidence. Good question. There is another way to do these problems. Do you want to see it, or do we remember this, want to stick with this?
Wait a second. If it's multiplied by 3.
No, you kind of, I think, are on the right track. Let's look at it. If you like the way we've been doing it and this is what seems familiar to you, stick with it. There is one other way we can do these problems. It still relies on us finding our slope first and using a point. But this way is you start off with y equals mx plus b. Right now, if they gave us a point and a slope, we have a y, an m, and an x that we could plug all those in, and then we would just have to solve for b. So my y from my point was what? 2. My slope was still 1/3. My x from my point was 3. And then I'm just left with a b to find. Okay, so in this one, 1/3 times 3 is 1. To get b all alone, I would have to subtract 1. So I get 1 equals b. The issue that I've run into with this method is that then students think they're done. But so far on this side, we have not written an equation of a line. We just found the y-intercept. So what do we still need to do with all that information? Okay, we got to put it back in. So then our final answer, again, would still be plugging in the slope and then plugging in that y-intercept that we just found. Okay. I don't really care which way you like. If you've learned both and you want to use one or the other, it's fine with me as long as you are showing your work and making valid mathematical decisions.
She said, hold on.
Oh.
It's fine.
All right, on this one, we are writing the equation of a line parallel to the equation y is equal to -2. Technically, on this one, we would have some options. What kind of line is y equals -2?
It's like straight up.
It's horizontal. It's side to side. So it goes through the y-axis horizontally. So if you wanted to sketch a little coordinate plane, if that helps you visualize this, you can. Okay, the line at y equals -2 is going to go side to side through -2. Okay, are we all in agreement about that graph? Okay, a line parallel to it is also going to have to be horizontal. So it's going to be another equation that is of the form y equals a constant. But because they didn't tell us where that line had to be, just that it has to be parallel, you kind of get to choose. Okay, you could use a positive 2. That would be a line that's just up to from the origin. Nope. It's closer. Can't seem to get it straight through there. All right. That would be one option. You could use y equals 18. I don't care. You could use y equals negative 55. Okay, they don't have to be something that'll necessarily fit on this graph, but it should be another horizontal line. All horizontal lines will be parallel to each other. Questions about that one? You actually have an infinite amount of possible answers. You would just have to give me one. Nothing? We're okay with that? Okay. All right. Ready to move on then? Okay. Write the equation of a line through the point, negative 2, 5, and whose slope is undefined. If the slope is undefined, what kind of line is it going to be? A vertical line. And we have to know that vertical lines have what form for their equation? They have an x-intercept. So horizontal lines are y equals. Vertical lines are x equals. This time they gave us another constraint though. It's not just x equals whatever number we want. It has to go through what x coordinate? Negative 2. Done. So you need to remember that undefined lines are going to have a form x equals some number. Not a hashtag, but a number. And then if they gave you an x coordinate, you need to use it. So x equals negative 2 is our answer. All right, 2 big ways of how to graph lines. The first one is using intercepts. Doesn't tend to be students' favorite way. I don't know why. Maybe it just gets confusing. To find the x-intercept, you plug 0 in for y, solve for x. To find the y-intercept, plug 0 in for x, solve for y. Plot your intercepts on their axes, put a line through them. Okay, so remember, intercepts are where the line crosses that axis. All right, for slope-intercept form, most students like to just use slope and the y-intercept. You plot your y-intercept, so you have a starting point. Then from that starting point, use the slope to plot more points. So you use your slope as rise over run to find more points to graph. Again, this should be a review. Do we have questions about it? I don't think you had anything to fill in. It was already there. Let's give it a try. This one I am going to do using intercepts because it's in standard form, not slope-intercept form. So we have to find our x-intercept and our y-intercept. So when we do that, we're basically trying to fill in the points 0, y and x, 0. So we're trying to form these points. So for this first one, that is going to be my y-intercept. I'm plugging 0 in for x. This is kind of like what we did in the warm-ups. I plug 0 in for x, and then I'm going to solve for y. What am I going to end up getting for y? 2. Okay, the 0 times 2 cancels itself out, goes away. Divide by 3, y is equal to 2. So I know the point 0, 2 is one of my points. To find my other point, this time I'm plugging 0 in for y. So I'll have 2x plus 3 times 0 equals 6. This time, what am I getting for x?
3.
A 3. That cancels out. We solve by dividing. X equals 3. Now, in my experience, the issue with teaching to graph with intercepts is that students say, oh, I have a y and I have an x. They must make a point. 3, 2 is probably not on this line. 3, 2 is not a point. To get the 2, we plugged in a 0. So 0, 2 is a point. To get the 3, we plugged in a 0 for y. So 3, 0 is a point. That's why I set these up from the beginning, so that way we wouldn't get confused and think that we made a new point with that x and y we found. All right, plot those points. 0, 2. Sorry, 0, 2. And 3, 0. And we can graph a line through them. That's pretty close. Questions about the intercepts? Concerns? Warm, fuzzy feelings? Silence. Okay, we'll move on then. All right, this one is kind of set up to do intercepts again, but I want to practice slope-intercept form. So I need it to be in slope-intercept form. How am I going to force that to happen, Sydney? Good, we need to add the x to both sides. Add x. Oop, wrong place. Over here. There we go. So we would have 2y equals... I would write this as x plus 4. They're both positive, so 4 plus x doesn't mean as much to us. Am I in slope-intercept form yet? No, what do I still need to do? Divide by 2. Everything gets divided by 2. Okay, so we have y equals, beautiful, 1/2 x plus 2. Okay, so you might be able to just go straight to your graph, but just to be a little extra, my slope is 1/2, and my y-intercept is 2, so that'll be at the point 0, 2. So I start off at my y-intercept, 0, 2. I use my slope as rise and run to get more points. So from my y-intercept, where am I going? Good, up 1, right 2. And I could keep doing that, up 1, right 2, up 1, right 2. Or instead of going up and right, I could go down and left, down 1, left 2, down 1, left 2. Now you don't necessarily need all the possible points that would fit on there, but the more points you have, usually the better of a line you can get. Wow, that does not want to go through there. That's as close as the iPad's gonna let me get, apparently. Okay. Remember, use a straight edge. Make it go through the whole graph. All those wonderful things. Questions, concerns about graphing or writing equations of lines? Okay. We got plenty of time to work on our homework. We do have quite a bit of it chunked up. Tomorrow, we are going to expect to have a homework check, and we are going to spend some time reviewing what we've talked about so far.